All right, so what we're supposed to do now is just find derivatives, basically. Okay, so we're given some function, and we need to find the derivative formula, or the derivative function of it. Okay, so we need to find h prime of x. Well, if we look at this, if we take and look at this, this is going to be a difference. So what we're going to do is we're going to take the derivative of that. Now this is a constant in front of another function, basically. And so what we can do is we can have find the derivative of the function part and then multiply that by the -7. And then after that, we should be good. So the derivative of a constant, well, that's 0. So if we go ahead and write that in, we'll have 0. Now, if we plug this in, well, that's going to be a -7 times the derivative of e to the x. Remember, e to the x is a special case, and its derivative is e to the x. So h prime of x is equal to just -7e to the x. All right. What about the next one? Here we've got two pieces. This piece has the x. This piece, that's just constant, just pi squared. Okay. So g prime of x is equal to, now remember, this is like some kind of an exponential, general exponential. So we're going to take the log of what that is. So we'll take the ln of 2.1, and then we're going to multiply that by the original function times 2.1 to the x. Okay. And then plus, well, pi squared, that's just a constant. So if we take the derivative of a constant, that's 0. And so we get 0. And so now all we have is ln of 2.1 times 2.1 to the x. Okay. And you could put the ln at 2.1 in parentheses and left the 2.1 to the x out of parentheses. You could put both in parentheses. It doesn't really matter, just as long as you make sure you don't have ln at 2.121 period, with all the extra stuff. So you have to kind of make sure you differentiate those there. So that's the only key thing there. Okay. All right. What about the next one? Well, this one says we have a hint. So if we have something a b to the cx, what they say to do is, well, take that b to the c, simplify it, and make it d, and then it's to the x. And so what they're saying then is, I think they want us to take this piece here and simplify it. And so then what we would have is 10, and then once we multiply that and take it to the power that, we'll have something, and that's going to be to the x. So now if we go into our calculator, we have the quantity 1 plus 0.05 divided by 4 raised to the power of 4. And so when I do that, I get 1 point, where's my pen here? 1.05094. Oops, I'm not even writing straight. I have to watch while I write and look at the calculator. All right, so 1.05094.5, and so on. And there's more there, but I'll just stop with that. Okay. And so that is really what I have for f of x. Now, what does this look like? Well, it looks like we have a constant times some exponential. And so f prime of x is going to be equal to 10 times, and maybe I'll put that in parentheses. Now remember, when we have the exponential, we're going to take the ln of 1.050945 times, and then we'll have this number to the x. So that would be our whole thing. Now, do we want to actually simplify this even further? We could say, okay, well, what is, 10 times this whole thing, and get that all done. But, I think at this point, oh, I left my ln off. Oh, there it is. ln of that. Okay, so, we could also, if we wanted to, we could simplify and get further down. But I think, we have a constant times this number and then times this to the power. So I think we could leave it at that, and we would be just fine with that. Now, another way I think we could do it is if we just left that d, we could take 1 plus 0.05 divided by 4, and that should be 1 plus 0.05 divided by 4. 1.0125, and we could leave that still to the fourth power, and then have that still to the x, and so we could have this not as the 1.050945, blah, blah, blah. We could just have it as 1.0125 to the fourth, and that would also fit in here, okay? But I think because it makes extra exponentials, I'm just going to leave it in this form because it said, let's break it all the way down. But I could see some people saying, well, let's just do this part and leave that for there and do stuff with that. So, but I think going ahead and doing it all the way like this is going to be the key in getting it to as far as you can go and making it simpler on yourself to do that derivative. All right, so let's stop there.